intense, but I'm going to try to simplify a very intense topic into just more of a method for you to do. So I'll try to reduce on the contextual understanding or content skill understanding. You're just going to learn how to do. I usually like to explain how things work, but I feel like given the time, we're just going to jump into each one, ideally what you need to know. Okay, so let's have a look here. I'm currently recording what you should have. Exercise 5, chapter 5. If we were to break down the key skills you needed, remember I said it was C and G. Those are your two main ones. Languages of the chapter is 5A, 5F. You can watch this video again to remind yourself. 5A and 5F is the language. Most of you got the general gist of how to use the notation, so I think 5A was good. Applying function notation, we've been doing that when I show you how to use a CAS. So when you use f of x, f of 1, f of 2, that's what function notation is. But I will say there is this question that you need to know what function notation overall actually means. And I'll show you when we do... Yeah, no, not that one. Where is it? This one. Can you see here, you will need to know how to write this style. This is what the year 12 by the end, when they ask you for a rule, they say state a rule, you always have to write your answer in this form. It's a 2-marker. Now it's become 1 mark because most kids know how to do it. But back then it used to be 2 marks because when you write it in this form, you will state the domain. They're looking if you had the correct domain and then whether you had the correct answer. It used to be 2 marks. So I will show you how to do that as we do 5G. Now, recap. 5A is language. 5B was domain and range. So if you understood how to find domain and range and use the notation to describe it, that's 5A and B. The main part was C. I talked about what a function was. You had to understand the 4 types of relation. Out of those 4 types, one-to-one, many-to-one, one-to-many, and then many-to-many. Those are the 4 types of relations, and only 2 of them is a function. So I had a video for that, 2 videos specifically, if you have a look. In fact, I got 3 videos up here. 5C, I did it prior to the classroom. This one we did in class when I described it to you. And then there's one where from mathsfactory.com, the guy does something similar to what I do. I like my videos better because the way I describe is different to the way he describes. But there's resources there for you. Okay? Then I show you video examples below. So if you wanted to see how I describe when is a function, how to use a vertical line test, horizontal line test, that's what these videos are for. Okay, so that's 5C and D. So 5C talks about what a function is, and you then can do 5D and 5C. So if you watch my one video, you should be able to do 5C, 5D. 5E sounds hard and kids hate it because most of the time they're still working on 5A to D. They don't even get to 5E, but technically 5E is one of the easier questions to do, or exercise to do. All you have to understand is what this intimidating thing looks like. That's all it is. If we read this, this is just saying h of x is made up of 2 different equations. That's it. That's all it is. They tell you the domain. They tell you the domain. So anything bigger than 0, sketch this graph. Anything less than 0, sketch that graph. That's why the exercise is called piecewise. I'm going to go over here. Piecewise defined functions. That's it. So in this video example, I show you how I've highlighted the 3 different regions. Less than 0, you sketch this. Between 0 and 1, you sketch this. Between greater than 1, you sketch this. And in the video, I actually show you how you get that by hand. So you have to know how to do it on a CAS. I'll show you how to do it on a CAS. And I also show you how to draw each section individually. And that's what I've done here. So you can see the 3 regions I've colored. Less than 1, 0 and 1, and then greater than 1. Looks hard, it's not. If you can draw straight lines, if you're okay with year 9 mathematics, it's just drawing 3 different graphs on the one axis. That's what it is. Okay? So you don't have to really know this. This is content-wise, it's not a lot of content, it's a skill. And it's based on whether you can sketch straight lines or sketch equations in general. So that's 5E. 5F was using your CAS, f of 1, f of 2, understanding that you can substitute a number in replacement of x. So this is an example here. I'll just go over here as an example. they'll say just understanding that f of 1 equals 7 is the same thing as saying x equals 1, therefore y equals 7. That's it. This is called function notation. All right? And there's a specific way to write it when it comes to a rule. That's 5f. So you can see 5e, 5f, very little in content. Where's the content heavy? 5c. What is a function? 5e, 5f is just skill-based. So you can kind of work through what you need to work on based on where you're sitting at. Today, I'm going to 5g because that's a content base. So there's a lot of content here. Usually, in my year 12 class, I can do a full 55, 70-minute theoretical explanation, but I'm just going to show you how. Okay, so I'm going to spend this session, I'm going to try to do it in 30 so minutes to explain what you do to find an inverse function and how you should write your answers. 5G or 5H, tie it all together, do an application. Okay, that's it. So really, the two content exercises you should be focusing on for the chapter SAC. Chapter 4 was sketching. You need to know truncus, square root, and rectangular hyperbole. Chapter 5, what is a function? And how do you do inverses? What's an inverse? That's it. So in terms of content skills, it's not a lot. In terms of the amount of work you got to do, yeah, there's a lot of skills there. But that's why you figure it out. You figure out how much you want to do in each section. But it's only those key skills you needed to learn. 5G, 5C, chapter 4. 3 functions to sketch. Okay? So as long as you've got that in the bag, you're okay. There's not too much to learn there. It's just content-wise, using your CAS. Okay? All right, so let's start with 5G. So I'm going to go back to 5G, inverse functions. I've got my videos here. You can watch how. So as I'm teaching you, if it's a lot, it's okay. You can watch videos how I do the questions. Yeah? But here's going to be the theoretical component. Now, inverse functions. Inverse literally is what your understanding of inverse is. It's the opposite. So the inverse of addition, subtraction. Inverse of division, multiplication. Inverse of squaring, square root. So when we're talking about inverse functions, there must be the reverse version of whatever function you've drawn. So there's a reverse of an x squared graph, which is the root x graph. There is the reverse of logarithmic graph, which is the exponential graph. That's what an inverse is. Now, on a theoretical sense, just for you to understand, on a very, very simple understanding here, this is what the year 12, where they ever put this question in, and they do, it's only worth 1 mark, or overall in the entire exam, it's worth about 5 marks in total. Right? In the entire exam, exam 1, exam 2. This is what they're testing. They want to know if you know that inverse functions only occur when you have a one-to-one. Okay, so this goes back to the understanding, what is a function? You have to have a one-to-one function to begin with in order to have an inverse, not inverse relation, but an inverse function. So that's a key word there. So in the exam, sometimes they say find the inverse relation. When they say inverse function, you need to show the examiners that you understand it needs to be a one-to-one. Okay, so what is a one-to-one? For every x value, there is only one unique y value. Okay, so a parabola is not a one-to-one, because when I draw a horizontal line test, you can see, for example, if it was 3 squared, if the equation was x squared, I can get 2 x values to get the same value of 9. Negative 3 squared gives you 9. 3 squared gives you 9. So that means this coordinate here is negative 3, 9, and this one is 3, 9. That means you can get 2 different x values, and you can still get the same value of 9. That's not a one-to-one. A one-to-one means there's only one x for one unique y. There's no other way to get the 9. There's only one x that corresponds to that one y value. This is called a many-to-one. Many x's to get the one y value. This is called a many-to-one. Okay? So that means if you were to find an inverse for this graph, it's not going to be a one-to-one inverse function. You see, what's the inverse of a square root? A square. So if you had y equals x squared, you see, the inverse of squaring is square root. But if you drew a square root properly, it should be this. That's a relation. That's not a function. You see, so that's why they're saying if you had a nice one-to-one, it'll be guaranteed that it's going to be a inverse function. Okay, how do you test if it's a function? Do a vertical line. If it crosses twice, not a function. If it crosses once, it's a function. Okay, this is all to do with 5C content, right? So I'm rushing through that right now. Yeah? Now, that was part of theory. So the one mark that you needed to understand, I'm going to rub all this out. The one thing you needed to understand was for you to have an inverse function, you have to have a one-to-one function to begin with. If you don't have that, you can't do it. Okay? So, here's the theory. When you do an inverse function, say a quadratic equation that looks like this, an inverse function is following this type of transformation. And I want you to get in the habit of writing this. When you're doing the calculations, this is how I normally write it. So I say inverse transformation. You don't even have to write that. You can then just do this notation. So copy this notation down, or when you watch the video, make sure this is going to be part of your working solution. The transformation is every xy coordinate on this function now transforms or maps to, that's what the arrow means, maps to yx. So you might have learnt this in, if you did an accelerated course, they would have said x equals y or y equals x. Okay, so essentially this is the transformation. So you know, like we've done dilations, you stretch it vertically, you times it by something, or you plus something, minus something, you move it left to right. This type of transformation is a reflection. And what type of reflection is this? This is a reflection. Imagine the mirror line was here. So the graph, if you try to, the way I like to teach my students to picture this, you see, if this is a mirror line, if you tilt your head, right, if you tilt your head, and align your head with this line, and you try to sketch a symmetrical section to it. So you sketch a symmetrical section. You see, if you tilt your head, I'm tilting my head right now, I can see, if I tilt my head, this will be symmetrical, this side is symmetrical to that side. Yeah? So imagine a mirror, that side is symmetrical to that side. This section here, I can then do a symmetrical section like that. Can you see how I'm tilting my head? This section is symmetrical to that side. So imagine there's a mirror here. Then this section here, if I want to do a symmetrical side to it, it has to go this way. True? So I'm just doing a symmetrical reflection. But if you put it together, can you see that's your square root relation? That's the square root, it's that curve. That's the reflection, that's the transformation that you're doing to it. You're not moving left or right, you're not moving up or down, you're not reflecting it over the x-axis or the y-axis, you're now reflecting it over this line. That's what this transformation is actually doing. Okay? So, when you're doing, that's the theory. So I'm going to stop there as a theory. What's special when you say the x coordinate becomes the y coordinate and the y coordinate becomes whatever the x coordinate is. So an example, here's an example. If you had the point 2, 1, this now becomes 1, 2. That's what you're doing, you're flipping it. Okay? And what's special about it, if you visualize it, you can see what I mean. 1, 2, 1, 2, 1 is over here. This is the point 2, 1. When you reflect it, imagine there's a mirror that's like this. If you reflect it, you expect it to be, if we had to tilt our head, it should flip over here somewhere. True? If you tilt your head, the mirrored image has to be over here somewhere. And you can see that if I swap the coordinates, 2, 1, 1, 2 is over here. Can you see that? They're just like mirrored images. That's what it is. It's a mirrored image along y equals x line. And so, not only do the x and y switch, what's special is the domain and range also switches. See, look at the domain. You were working with 0 to 2. Now the range is 0 to 2. The height before was only a distance of 1. Now, the length is a distance of 1. See that point? It's only a distance of 1. So what's happening here, and this is one of the key definitions that you have to have, and there's only 2 things that you need to know. This one, the domain of the original function ends up being the range of the inverse function. The range of the original function is now the domain of the inverse function. It's just flipped. Whatever x was, it becomes the y. So the domain of x now becomes the range of the inverse. That's it. They're all swapped. So I'm saying, not only in an equation, say y equals to x squared as an example, right? Not only does x now become y, not only does y become x, so you get x equals to y squared, right? Not only that, the domain and range for each one, so the domain of the function and the range of the function now swaps, and it becomes, whatever the domain is, it is the same thing as the range of the inverse. And whatever the range is, it becomes the domain of the inverse. So really, what have I just taught you? Two things, two conceptual ideas. Very simple. One was the swapping of the x and y's. Two, domain becomes range, range becomes domain. That's literally what these two boxes are. See those two boxes there? That's what they're trying to tell you. They're trying to say y becomes the inverse, x becomes the y. That's what they're trying to say. You swap the x and y's. That's one point. What's your second point? The domain of one, the original becomes the range of the inverse. The range of the original becomes the domain of the inverse. That's it. Two concepts. And that's what I use to answer each and every one of the questions. Okay? That's a theory. Let's do some examples now to tie it in so you feel a bit more confident. Okay? That's all I want you to learn. So I've cut down what I normally teach over 2 sessions with my year 12s. I'm cutting it down to 16 minutes. Okay? So that's literally what you need to know. Two things. X becomes y. So I want you to use this notation over here. X becomes y and y becomes x. Use that notation. And number two is, don't forget, the domain of the original becomes the range of the inverse. The range of the original becomes the domain of the inverse. Okay, just two boxes, two key skills. Here we go. Let's tie it all together and do some examples, okay? Here we go. I'm going to do, I want to get one that you can see a bit easier. All right, they're all a bit nasty. All right, let's just do, I'm going to do this one, okay, just to highlight my point. Actually, would that be too much to start off? Yeah, maybe that's too much to start off with. Let's do this one. I'm going to do A. Here we go, 3A, just to illustrate my point, okay? Why can't I screenshot? All right, A. Here we go. Let's do A together, and you see the method. I'm only using two things to do this question. First part of the question says, find the inverse function. How do you do that? Here we go. This is, if we're reading this right now, this is always the domain. So write down your notes. This is the domain. In my videos, I do explain this as well. But right now, all you have to care about is this section is the domain. So domain of f is currently equal to 0 to infinity. That's the domain. What's my function? My function is equal to x squared. Now they want you to find the inverse. So remember, there were two things that you needed to remember, two concepts. This is how I want you to do it, okay? So watch my layout and then you copy exactly the way when you're doing in your Saxon exams, okay? From here, I like to use x and y's. So I say, let f of x equal to y. You have to state that. You can't just introduce a y variable out of nowhere, right? The reason why I do that is because then it becomes y equals x squared, which is easier to see, right? Here's the first dot point. So remember the first skill I said? X becomes y becomes x. So I told you to write this sentence down. X, y, maps become y, x, transformation. See what I'm doing? So I'm showing the examiners that this is what I started off with. I'm going to let f of x equal to y, and this is what it looks like. And I'm now saying for every coordinate over here is going to become x becomes y becomes x, transformation. See what I'm saying? So my method is clear, and this is what happens to the equation now. Y becomes x, x becomes y. That's the first point. So that was the first skill. So I'm showing you the how. First dot point. Then, how do you find the inverse? Rearrange it to get y by itself. So how do this is where you do the inverse of squaring. So what's the opposite of squaring? Square root. So here we go. I'm going to square root both sides, and I get y is equal to the root of x. I'm square rooting both sides. Okay? Yep.
Is it plus minus root x?
Correct. Very good. So this is technically meant to, and this is very key here.
So remember, what did I say before? Parabolas aren't a one-to-one. It's not a one-to-one function. Oh, sorry, yeah, it's not a one-to-one function. It's a many-to-one. So you shouldn't have an inverse function. That's why it's meant to have plus minus, but that's why, look at the domain again. They told you only to sketch half of the parabola. It's only from 0 to infinity. It's not every number, it's only from 0 to infinity. So if you think about it, it's only half of a parabola, which is a one-to-one. Okay, but I'll talk about that soon. I'm just showing you the method. This is your answer. But how do you properly answer the question? They asked you to find the rule for the inverse. This is how you do it. The y value, I made that one up. That doesn't exist. So when you write your final answer, it has to be in terms of what they gave you. They gave you f of x, so the inverse to it has to be f inverse of x. This is my inverse function. But when you write a rule in year 12, they want you to write it in function notation. This is called function notation. So have a look. This is function notation. So you need to write, what letter are we working with? I'm working with f inverse, colon. See what I'm doing? I'm copying exactly what I have here. Next part is the domain. The domain of the function I still haven't figured out. I don't know what the domain of my inverse is, but this is why you use chapter 4. This is a square root relation or function. What's the domain or implied domain of a square root function? Positive.
Or any of the positives.
Very good. So this is where if you know your square root functions, you can then figure out clearly the domain is from 0 to infinity. Now if you don't know that, we can try to sketch this, find the range of this, and that should be the domain of that. Okay, so here we go. I'm going to write it again just in case you're confused. If you ever struggle to find the domain and range, so here I need the domain of f inverse. I need to find the inverse of the domain of the inverse. If you don't know how to find that, it's okay. Go back to this one. Because remember, the domain of the function is equal to the range. This is point number 2. Range of the inverse. We've already got the range of the inverse because we got the domain of the function. They gave it to us here. It said the domain is 0 to infinity. What we don't have is the range of the function. See, if you're unsure, sketch the original function. If you don't know what the domain of the inverse is, this is what you want, sketch this. What does an x squared graph look like? We all should know that. So we sketch it. Here we go. That's what my graph will look like, but they said the domain is only from 0 to infinity, so I can't sketch the left side. I have to sketch only the right side, from 0 to infinity. That's what my graph looks like. So now if I ask you, what's the range of that graph? That's the range of my f. So what's the range of this original function? It's 0 to infinity. Okay, so if you know that, this is now 0 to infinity, that tells me I now know the domain of the inverse. I'm using point number 2, concept number 2. So there's 2 things. 1, y becomes x, x becomes y. That's the first step. Second step, when you're writing your answer, you need to use this point. Domain of the original function becomes the range of the inverse. The range of the original function becomes the domain of the inverse. Now I know the domain of the inverse has to be 0 to infinity. So how do you write it as a function notation? 0 to infinity maps onto r, comma.
Is it always on?
Always r. And in my videos I explain what that is. Just to quickly summarize, that's what we call the codomain. And some of you might be like, what's a codomain? Literally just means, where are you drawing 2 to infinity from? You see, in mathematics, we don't always work with numbers. Sometimes we work with complex numbers or whole numbers systems. So they want to know where you're drawing it from. So in my videos, I explain it like ice cream. You see, you can think of the codomain as all the ice cream flavors you can choose. So now how many ice cream flavors are there? There's like pistachio, chocolate, vanilla, strawberry, chocolate mint, right? There are infinitely many. I'm assuming infinitely many. But the domain, I'm only going to choose a few. I might just choose chocolate and strawberry. That's my domain. So where did I get the ice cream flavors from? I got it from the list of ice cream flavors. So this R, in methods, we only deal with numbers. We don't deal with complex numbers. That's why it's always R. Okay, so that's easy for you. It's always going to be arrow R, and then comma, write down your function. So what you see down here, that's the answer when they want you to find the inverse function in year 12, that's the proper way of writing it. That's the proper way of writing it. Okay, and in more depth, you see which one, when Ollie asked me before, you've got a plus or a minus answer here. If I sketch this inverse function or inverse relation, which one corresponds to a domain of 0 to infinity? They both have 0 to infinity. But which one of those, you see, we know that the range of the inverse is equal to the domain of f, which is 0 to infinity. So which one has 0 to infinity as a range? Which one has a range of 0 to infinity? Is it the top half or the bottom half? Which one? This is the positive root. This is the negative root. Which one represents 0 to infinity? It's the top half. Because that's the one where it's 0 to infinity. That's why we know the answer is positive and not the negative version. But that's based on what they gave you. So in year 12, you'll find that they actually do it the reverse. Because a lot of students would just write root x. And then in the exam in year 12, they purposely do it so that you were meant to choose the bottom half. And the only way to know that is you had to find the range of the inverse to determine which one was the correct one. That's why it becomes a very complicated question. Okay, so it delves into how well you understand it, but it comes down to two things. A function has to be a one-to-one to have an inverse function. And number two, the domain of the original is the range of the inverse. And then range of the original becomes the domain of the inverse. Okay, so that's the only two skills worth 5 marks in total, generally, for the entire exam of it. But it's very typical. What I'm showing you right now is a very typical question for year 12. Okay? So, what I've just shown you is to answer that question. Now, they asked you to state the domain and range of the inverse. We happen to have done it already. You see, in that process, I've shown you how to do them all. I do have the range of the inverse 0 to infinity. They gave that to us. How did I find the domain of the inverse? I had to sketch the original. And then I realized, oh, it's from 0 to infinity, and I got the answer too. Okay? There's a lot of ways to find the domain or range, but you have to play around with it. But this right here is a skill. So I taught you the theory in 16 minutes, and then I showed you the how. This is what you will learn to practice. Most of you should be able to do this section. So swapping the x and y's, do the algebra until you get the y, that's your inverse function. From there, depends if you can find the domain or not. Okay, so this is where some of you will struggle, but most of you should be able to get this step. So at least you get a mark. Okay, so no matter where you're going, every one of you can possibly get the first mark by the first dot point. Okay, so have a look at that example. I'm going to leave it there. That's what 5G is. Watch my videos if you want to see more complicated questions, but that's the theory. It's only two things. X equals y, y becomes x, domain and range swaps. That's it. Two key skills that I used to answer this question. That's the algebra component. That's my final answer. And that's how you should be working throughout each exercise. Okay? That's 5G in a nutshell. And mind you, I teach this over 2 sessions normally. I'm doing this in a massive express.